welcome back. This is lesson 10.2/10.3 area of triangles journal. I will be able to understand the relationship between a parallelogram and a triangle and use it to find the area of any triangle. I will be able to identify the base and the height of any triangle and use those to find the area. Alright, vocabulary for this lesson. Congruent, exactly the same size, exactly the same shape. Area, the space inside a two-dimensional figure, and it's always measured in square units. So you can see the squares inside of this. How many squares fit inside that shape is its area. Dimension is the distance measured in one direction. So one-dimensional would be like a line. Two-dimensional, see how this has a base and a height that I can measure? Three-dimensional would be like a three-dimensional object where I can measure the base, height, and the side, the depth. Okay, right angle is a square corner, 90-degree angle. The base is usually the bottom, but it always forms a right angle with the height. And the height is usually how tall something is, but it also always makes a right angle with the base. So these two are connected to each other. A parallelogram has two sets of parallel sides. So you can see this figure. These are parallel to each other, and these are parallel to each other. This is a parallelogram. So is this one, but this one specifically is a rectangle because it has four right angles. Okay, we're going to add one to our page. So pull out page 136. We're going to add one word. Okay, a triangle. A triangle is a three-sided polygon. And just as a reminder, we have three kinds. We have an equilateral triangle, which has all sides the same. An isosceles, which two sides are the same, one's different. And then we have scalene, where three of the sides are, all three are different from each other. Alright, I'm pretty sure you knew what a triangle was anyway, but just a quick refresher. Alright, let's try this task. It says, what is the area of figure M? So figure M is a rectangle. So to find its area, we're going to do the base, which would be 1, 2, 3, 4 times its height, which would be 1, 2, 3. So base times height, and that gives us 12 units squared. It says now divide figure M into two congruent triangles. So not just any triangles, two triangles that are exactly the same. Well, if this is 4 and this is 3, this is also 4 and this is 3. If I just cut it right from one corner to the other corner, straight across that diagonal, I'm going to make two equivalent congruent triangles. So it says, what is the area of each triangle? Well, it was 12. So if I just cut it in half, that means it got divided by 2. So 12 divided by 2 would be 6 units squared. Why? Because we cut the rectangle in half. Alright, now it says, what is the area of figure N? So using what we know about parallelograms, base, we can call this a base. I can measure this one, so that's what I'm going to do. So 1, 2, 3, 4. So my base is 4. My height from base to base is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4 times 9 4 times 9 equals 36, so this would be 36 units squared. Now divide figure N into two congruent triangles. Okay, easiest way to do that again is to cut it from corner to corner. This one is not as easy to cut perfectly, so I'm going to pull out my ruler. But if I cut it from corner to corner, I'll have two triangles with exactly the same sides. So what is the area of each triangle? Well, once again, we just cut it in half. So 36 divided by 2 is going to give me 18 units squared for each one. Why? Well, we cut the parallelogram in half. Or in other words, two equal pieces, right? To make the triangles. Alright, what is the area of figure O? Base 1, 2, 3, 4, 5, 6, 7. So 7 times 1, 2, 3 is its height. 7 times 3 is 21 units squared. Now divide O into two congruent triangles. Okay, I'm going to pull out my thing again. It doesn't matter if I cut it this way or the other way, as long as I go diagonal from corner to corner. Now I got two congruent triangles. So it says, what is the area of each triangle? So looking at that, my base is 7, my height was 3, so that means I'm just going to end up doing 21 divided by 2, which is the same as 10 and a half, or 10.5. So 10 and a half units squared. Why? Because each triangle is half of the parallelogram. Now turn both figure P and figure Q into parallelograms by drawing a congruent triangle on the grid paper. How can you use this parallelogram to help you find the area of each of the original triangles? Okay, so does that say? Okay, so if I want to make this into a parallelogram, looks like this has a base of 4, I can measure that. So imagine this is where it got cut in half. Then that means I've got to go 4 this way. So there's my base of 4, my matching base up here. And then I can just connect this to that corner. So there's my parallelogram. So that gives me a base of 1, 2, 3, 4, and a height of 1, 2, 3. Okay, let's turn this one into a parallelogram. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, one thing I want you to notice. Do you notice how I'm counting on the perfectly horizontal or perfectly vertical spots? That's because I can't measure this distance on the diagonal the way it is. I don't know exactly how many units that is, but I can count this one. So if this is 10, that means my parallelogram, this would be one of the slanted sides, that means I can make this up here 10. So I'm going to go back 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, all the way back to here. Now let's see if that looks about right. This looks like it sticks out 2 more from here. That sticks out 2 more. Okay, that's about right. And I connect this back to this corner. Okay, so your parallelogram, 2 identical congruent triangles make up the parallelogram. So it says, how can you use this parallelogram to help you find the area of each of the original triangles? Well, the base is a flat one I can measure, and then I can look at the height. So to the height of the tallest point, if I were to turn it over, I could see that that was 3, so I got my base and my height like I would in a parallelogram. But then how do I get the triangle? Well, just divide it by 2. So if I can identify the base and the height, and then I can divide it by 2. So we can find the base and the height. And multiply them together. Then divide it by 2 because a triangle is half of a parallelogram. I'm trying to fit it all in there. Oh, you can't even see what I was writing. I'm sorry. So find the base and the height and multiply. Then we can divide it by 2 because a triangle is half of a parallelogram. So what is the area of figure P? So the base up here was 1, 2, 3, 4. The side I could find a measurement on, and then from there I have to make a right angle, which I can see here with my grid lines of 1, 2, 3. So it's going to be 4 times 3, and then I'm going to divide that by 2. Base times height, and half of that. So 4 times 3 is 12, and 12 divided by 2 would be 6. So that would be 6 units squared. So what about figure Q? Well, the one I could count was 10. So if my base is 10, this one has a height from base to the top point. 1, 2, 3. So this would be 10 times 3, but then I have to divide that by 2. 10 times 3 is 30, and 30 divided by 2 is 15. So it would be 15 units squared. Now it says, how can you use what you've learned from this exercise to find the area of any triangle? Well, we can find the base. And height. In other words, we're looking for the right angle. So find the base and height. Multiply. Then divide by 2. Alright, let's use that on these problems. So, formula of the triangle. Area of the triangle is base times height, then half of that. Base times height, then half of that. So looking at this is 14 meters, and it makes a right angle. Notice how it's over here on the side? That's because I couldn't draw a right angle going up to the top, so they drag that out here so that you can see that right angle. So with the ground, it's 10 units tall. So base times height, 14 times 10, and then we're going to divide that by 2. So 14 times 10 would be 140, and 140 divided by 2 would give me an area of 70, and in this case it's meters squared. The only thing that's different between this and a parallelogram is it's half of a parallelogram, so you have to divide it in half. Oh, this one didn't copy off very well. This is supposed to say 30 on it. So put 30 there. Alright, so if that's 30, which measurements form a right angle here to help me with my area. 56 and 30 go together. So I'm going to do 56 times 30, base and height. 65 is useless for this because it doesn't form a right angle with any of the other measurements. But then I have to divide it by 2. So base times height, 56 times 30, I don't know what that is off the top of my head. 0, 0. 3 times 6 is 18, regroup 1. 3 times 5 is 15, plus 1 more is 16. 0, 8, 6, 1. So that's 1,680. But then I have to cut it in half, because that would be if it was a parallelogram. So 1,680 inside the box, divide by 2. 2 goes into 16 8 times, minus 16 gives me 0. Bring down the 8. 2 goes into 8 4 times, minus 8 gives me 0. Bring down the 0. 2 goes into 0 0 times. So in other words, this has an area of 840. This doesn't give me any units, they're just numbers. So we're just going to write units squared. Okay, this one says, if the area of this triangle is 100 units squared, what is the height of the triangle? Well, looking at the height forms a right angle with 20. So that tells me 16 and 12 are useless information for what I'm trying to do. Okay, I'm looking for the height, so let's plug in what we know. Base is 20 times a height, which I don't know, but then it got divided by 2. And that's going to end up giving me 100. Okay, this is where you got to think backwards. 20 times something, then it was divided by 2 to get 100. So if I want to figure out what this timesing is, I've got to undo dividing by 2. So I'm going to times by 2 to get rid of this, which means I got to times this by 2. 100 times by 2 is 200. So in other words, before we cut it in half, it would have been 200. That makes sense. So 20 times something gives me 200. Now some of you in your brains are saying, I know what this is. Others are like, I don't know. Well, I'm timesing 20 by something. So to undo timesing, I'm going to divide here. So divide by 20, divide by 20. H is equal to 10. So the height was 10 units tall. Now why did I not put units squared here? This is a one-dimensional measurement, so this is a one-dimensional answer. Area is a two-dimensional measurement, so we have to put it in 2 dimensions. Okay? If the area of this triangle is 84 units squared, what is the length of the base? So here, we know the height, which is 24. We don't know the base, but we know that the area is 84. So, I'm going to put base times height, which I don't know the base, but I know times the height is 24. And then I divide that whole thing by 2 to get 84. So now we gotta go backwards. Last thing we did was divide by 2, so I'm going to times by 2 and cancel that out. So times this side by 2. That means if it was a parallelogram, it would have been equal to 168. Now that leaves me with b times 24. How do I undo timesing by 24? We divide by 24. So I'm going to divide this by 24. So 168 divided by 24. 24 doesn't squeeze in here or here, so it's got to be less than 10. I'm guessing about 7. Let's see, 24 times 7. 7 times 4 is 28. Regroup 2. 7 times 2 is 14, plus 2 more is 16. That's perfect. So 7 minus 168 equals 0. So in other words, b is equal to 7. What did that mean over here? The length of our base. So that would be 7 units. Once again, that's one-dimensional because I'm just measuring the base. One direction. Okay, rate yourself on this concept, 0, 1, 2, 3, or 4. take a picture of both pages and turn it into Google Classroom.